Welcome to this tutorial about Allen Bradley SLC PLC with DeviceNet. I'll use a physical SLC to set up a system from scratch, and once you understand all the tools, you'll be able to maintain, troubleshoot, recover, and modify your DeviceNet system. Now, as you can see, our 503 controller has a major fault. Our scanner is also not happy. The controller will not going to run because of the major fault, and generally speaking, it's not happy. Now, let's have a quick look at the DeviceNet network. Beyond the scanner, it also has a retroreflective photo eye, and that blinking light, that blinking LED is indicating that the sensor is not in the scan list. Now, we also have a push button that's wired directly into an input card, nothing to do with the DeviceNet. That's just for a little variety. Now, we'll be communicating directly to the processor using the 1747 UIC cable. This is going to allow a connection between our laptop running all the software to connect to the processor. Now, before you get any farther into this video, let's hit pause real quick and talk about what this video is gonna walk you through. We're gonna set up the driver and RS links for the 1747 UIC cable. We're also gonna set up a pass-through driver, which is the only way to load the DeviceNet configuration into the DeviceNet scanner without physically being on the DeviceNet network. Another thing we're going to do is we're going to look at RSLogix 500 to figure out what the major fault is as a hex code. We're going to configure the MO and M1 memory sizes. That is part of setting up the pass-through driver. We're also going to enable a bit to exchange data between the 503 processor and the DeviceNet scanner. And we're going to access the data using the program in the simplest terms. We're also going to use RS networks to create a project via drag and drop. We're also going to configure the scan list, do memory mapping, and download everything to the DeviceNet scanner. Now, if you understand all of the tools that this video covers, you should be very well on your way to maintaining these networks, making small modifications, and generally being able to do whatever you need to do with a slick DeviceNet system. Without further ado, let's get our hands dirty. Let's roll. Alrighty. So, the first thing that I'm going to do is I'm going to connect the cable to my virtual machine from the host. I am running a virtual machine with Windows 7 with the Allen Bradley software suite. You may have it installed natively on your laptop, whatever works for you. And basically what I'm doing right now is with the cable connected, I want to open the device manager operating system window to see what serial port was allocated, and in this case it's COM4, sweet. So now let's fire up RS links and let's configure the 1747 UIC driver so that the Allen Bradley software suite can communicate from the software to the PLC using the cable. Now, my cable has a selection between the RJ45 connector and the DB9. I use the RJ45 and I have the selector configured as DH485. So that's why I gave it that name. And now since the cable is connected and the driver is created, the RS Link software found the processor. It is 01 default. It is the 503 processor. And next, let's fire up RSLogix 500 so we could create a blank project to go online and figure out what the fault code is. So first we're gonna select the processor, and now it's giving us the fault code. it's telling us it's 002H. The H stands for hex. And if you look in the SLC 500 reference manual on page 439, you're going to see that it says the controller was unexpectedly reset due to a noisy environment, blah, 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 blah. You're going to have some other fault, but that's where you're going to collect your fault from the SLC 500 reference manual, page 439. And Bob's your uncle. Now, in order to get everything going, I am going, in theory, you should have a backup of the software that's running on your processor. In my case, I don't, so I'm creating everything from scratch. And basically, I've stated what is my processor, how many, the slots in my rack, and I got the software to read the cards. Now, MO and M1 for DH485, the max limit is 361. If you go 362, it won't work. It'll be too small. It is 395 for the SLC 504 and the 505. And if you use a DH plus cable, it's much easier because it is at a speed of 56 kilobits per second, whereas DH485 is limited to 19 kilobits per second. So I'm creating everything from scratch so that you understand how your project came into existence. However, you should have this backed up. And if you don't, it is a very good idea to back it up. Otherwise, you could find yourself in some hot water. So I've configured the processor, the chassis, the cards. I've configured my communication ports, and now I am downloading to the PLC. In theory, in practice, you should have your SLC 500 RSS file uploaded from your controller, and you would have the same exact circumstances as me. It's just that I'm creating everything from scratch. And now that I'm able to go online, offline, I got communications, everything is happy, I'm pretty much done with RS Logix 500 for now. Alrighty, so right now we're going to use RS links to configure the pass-through driver. Now, what's interesting is that DeviceNet is an older technology. It's more than 30 years old. And what Allen Bradley used to do is they used to sell DeviceNet communication cards for your physical personal computer and laptop, so you could connect them to your computer and then be a node on the actual DeviceNet network. But who the hell has one of those things? And for those rare cases, they created this pass-through driver. And one thing that I validated is the manual talks about using DH plus and Ethernet. However, I use DH485, which is significantly slower. And if you grab the manual, it's the same steps, except I am further showing that, yep, you can do it with DH485 as well. Now, basically what I'm doing here is, in order to get the pass-through driver to work, is after you've created it in RS Links, you have to go into run mode at least once, and then the pass-through driver will work. So that's what I did there. I went to RS Logix 500, and instead of flicking the key back and forth a couple of times, I just used the drop-down menu, because that is what's being, that's what you can see on your screen. All right, so we got the pass-through driver set up, And now we're going to fire up RS Networks and set up the network. Now, you should have a .dnt file for your DeviceNet network. I'm going to create mine from scratch. If you understand all the steps, you'll be able to recover. However, it's much, much better to have a backup ahead of time in case anything crashes. And if you don't have a backup, you can always upload from your scanner. So the first device that I dragged and dropped is the scanner for DeviceNet, and the default address is 0. And right now I am looking for the correct sensor, which is a DeviceNet sensor. And there you go. I plop it down. Now, the DeviceNet sensor is configured as address 7. So right now I am in the configuration, I am making sure that it has the same addresses as the physical network. And right now I'm going to save this project before it'll allow me to communicate with the DeviceNet scanner. And actually all the devices on the network for that matter. All right, now we're going online. Very exciting. We're going to tell the system we're using the pass-through driver. All right, so it's saying upload. So now we're uploading from the scanner. Now this is unusually slow. However, the mere fact that it works is a miracle. With this older technology, some of the problems is that you may not necessarily have the hardware kicking around, which is now really rare. I mean, like, where the hell are you going to find the DeviceNet? It's a gong show. So the fact that we can use a regular UIC cable is a godsend. And actually the UIC cable works for every single one of the 5 processors that are available. So 501, 502, 503, 504, and 505. So that's pretty good. Okay, so now we're looking at the properties of the scanner, and before we can go on the module tab, we have to upload. So, for example, if you have one of these in your plant and you got to this point and you didn't have a backup prior to this, well, guess what? These are the steps to create the backup. So if your DeviceNet network ever goes down in the future, you could replace the card, dump in the DNT file into the scanner, and Bob's your uncle. So I hope you can see the value to this video where it's walking you through the steps, but the steps are validated because what you're seeing is actual work performed on a physical SLC with a physical scanner with a physical network. So it's pretty cool. And slow. Pretty cool and slow. Fun fact, if you click on the right part of the screen in YouTube, it goes into 2x speed. So this is what I would do if I was you right now. Go into double speed while we're uploading from the scanner. Alrighty, now I would drop down from double speed to regular speed. What's going to happen as soon as we're done downloading is we're going to jump on the scan list tab. In the scan list tab, you're going to see on the right hand side, you have all of the devices that are configured in the scan list, which the DeviceNet scanner is scanning. We can see this Note 5 is no longer there, so we're going to remove it, and we're going to add the available device from the left part of the screen into the scan list. Make sure you uncheck auto map on add. Now that you've added it and you apply, what happens is you download the scan list into the DeviceNet scanner. What we're going to do next is we're going to jump into the input tab and we're going to map the memory. I am using M memory, where M1 is the memory type, 1 is the card, and 0 is the word. And I have pressed auto map and I have mapped bits 0 to 7, where I'm only using, actually the sensor only uses bits 0 and 1, where 0 is the status of the sensor and 1 is doing the status of the sensor in terms of is it down or is it up, whereas bit 0 is checking is it blocked or unblocked. So at this point now, we're pretty much done with RS networks for DeviceNet. We're going to save the project. Now, if for any reason you got to this point and you realize, I don't have the software, or it's too much to bite off, or you need the system working right this very second, or the tutorial didn't cover something, and you need some help, that brings us to the sponsor of this video, Able Automation Solutions. They have graciously provided the hardware and the knowledge for this video, and they know industrial automation inside out. Regardless of the machine type that you have, if you're having a problem with your machine, give them a call. Whether your machine is down and you need to recover it, whether you have obsolete hardware, whether you don't have your software backed up, if you want your machine to do something different, give our sponsor, Able Automation Solutions, a call. They have been around for a long time. They're tremendously experienced. And if you give them a call, they will come by and help you out. They are based out of the Greater Toronto area. However, if you need a hand, give them a call. Alrighty, coming back to where we were, we're pretty much done with RS networks for DeviceNet, and now we're going to fire up RS Logix 500 so that we can use the information or the data coming out of the DeviceNet scanner, which is specifically the status of the photo eye, which is a node on the DeviceNet. So in order to get any information out of the DeviceNet scanner, we have to set output word 0 in the image window, bit 0 to 1. This enables communication between the processor and the DeviceNet card. And we can see that I have set it to 1. So at this point now, the controller, and I have validated that it is set to 1, and now the 503 SLC controller has access to the data coming out of the DeviceNet scanner. Now, because we're using the M0 and M1 memory areas, there's no image window to show us the status of all of the bits. So what I'm going to do next is I'm going to use a copy instruction to copy 2 words out of the M1 memory into the N7 image table so that we could visualize and see the status of the data that we're importing in those first 2 words. Now, if you'll remember, we used word 0, bit 0 was the status of the photo eye, meaning when I say status, I mean the status, is it blocked or not blocked, not the hardware status, as in is it happy and communicating and all that stuff. Okay, so now that we're copying 2 words, which is 32 bits out of memory 1 into N7, let's download the project, and then we can open the N7 image table, and then we can see the bits. All right, now we can see that it's 1. Now with my hand, I am physically blocking and unblocking the sensor, and we can see that the status is changing. However, let's put into binary so we can see the individual bits, and there we go. as I block and unblock the photo eye, I'm getting the representation of that photo eye being blocked and unblocked in memory. So what I'm going to do now is I'm going to have a little bit of fun with this project, and I am going to create a very small program where I count the number of times that the push button is pressed, and I count the number of times that the photo eye is blocked, and if the photo eye is blocked 5 times, or if the push button is pressed 5 times, then I turn on an output, and once the output turns on, a timer starts, and within 3.5 seconds, the timer resets the counters, and the timer turns off the output. Once I stretch out the window, you can see this very simple program. You can pause the video and basically have a quick look at what I just described. And first, what I'm going to do is I am going to show how the program works via the program. I'm going to press the physical push button 5 times, which is going to increment counter 1, and I'm going to block the photo eye 5 times, which is going to increment counter 0. And as each counter is done, I'm going to turn on an output and start a timer. And when the timer is done, I reset the counters. Okie doke. And now let's have a view of that by looking at the hardware. All right, so here's the hardware. Everything is happy. No major or minor faults. The processor is in run. The DeviceNet is scanning. So I'll press the button 5 times and the output turns on. 3.5 seconds later, it turns off. So that is working. And now, drum roll, let's do the same for the DeviceNet. Let's see how the DeviceNet works. There we go. I block it. I break the beam of light, which then does have the same exact result. All right. Thanks for watching. Hope you found this information helpful, and see you around on the next one. Ciao.